Hello all, welcome to my engineering physics channel. In session 1, we have started fundamental of photonics laser part. In that part, we are discuss about the lasers, full form of laser, different processes of the formations of lasers and the difference between spontaneous emission and stimulated emission. Now, in this session 2, we are discussing some basic prerequisite for the formation of laser. So let's start the session. So first requisite is your population inversion. So this population inversion process can be given by using the Maxwell distribution formula. So according to Maxwell-Boltzmann distribution, the number of atoms per unit volume in a excited energy level capital E for the gas in thermal equilibrium can be written as N is equals to N0 e raised to minus E upon Kt, whereas N0 is constant, K is Boltzmann constant and capital T is absolute temperature. Now we are considering the two energy state, that is E1 and E2, and the energy of higher excited state is greater than that of ground state. So this equation of ME distribution can be written as, for the ground state we can write as N1 which is equals to N0 e raised to minus E1 upon Kt, and for excited level we can write as N2 which is equals to N0 e raised to minus E2 upon Kt. If we take the ratio of N2 upon N1, we can write this equation as E is equals to minus in bracket E2 minus E1 upon Kt. As we consider the energy of excited state is greater than ground state, this term e raised to minus E2 minus E1 upon Kt is less than 1. Therefore, the condition that is N2 is less than 1, N1. That means the number of atoms in a lower energy state is greater than that of excited state. To increase the probability of stimulated emission, we have the more number of atoms in a higher excited state than that of lower energy state. So this state in which there is a large number of atoms in a higher energy state than that of lower is known as population inversion. That means the number of atoms in a higher excited state should be greater than the number of atoms in lower state or the ground state. This condition is known as population inversion, that is N2 is greater than N1. So this population inversion ensures the amplification of light and this system is known as active medium. And the population inversion condition is not equilibrium state of system. That means in this case the number of atoms in a higher excited state is greater as compared to the ground state. So it is not equilibrium state of system. Now the next prerequisite is pumping. So what is mean by pumping? For stimulated emission, it is our condition that the more number of atoms should be present in higher excited state so that the population inversion can achieve and the stimulated inversion process or the stimulated emission process will be happens and we will get a more number of atoms or the laser. So that for this process we are using the pumping. Pumping is nothing but the raising the atoms from lower energy state to the higher energy state. To achieve the population inversions, the atom in a lower energy state has to be pumped to the higher energy state by providing some energy. And this energy may be optical pumping or electrical pumping, chemical pumping or direct pumping. In optical pumping, we are using light energy to pump the atoms from lower to higher state. Electrical pumping, we are using the electrons to pump atom from lower to higher state. In chemical pumping, we are using some chemical reactions to pump the atoms, and in direct pumping, the electrical energy is converted into a light energy. Now, next prerequisite is active medium. So what is the active medium? The medium in which your light amplification takes place is nothing but active medium. As we see, some atoms produce spontaneous emission, whereas some produce stimulated emission. Those atoms which cause a laser action are called as active center, and the medium hosting these active centers is nothing but active medium, or we can say that the medium in which your light amplification takes place is known as active medium. So there are three types of active medium, that is solid, liquid and gas. So solid active medium uses a solid mixture of some materials. So solid active medium is used in ruby laser, neodymium dope, yttrium aluminum garnet laser, that is NdArc laser, and the liquid active medium, that means some mixture of liquids, is used for the formation of dye laser. Now the third one is gas mixture is used for the formation of HNE, that is helium neon laser, and CO2 laser, that is carbon dioxide laser. So this is known as active medium. Now next is resonant cavity. So this resonant cavity consists of two mirrors. So the cavities can be constructed by using two reflecting mirrors as shown in figure. Here it is your one mirror and here it is your second mirror. So the resonating cavity by using these two mirrors, in which the mirror M1 is your 100% reflecting. So this mirror first is your 100% reflecting and mirror M2 is 90% reflecting and 10% transmitting. For some cases, it is 95% reflecting and 5% transmitting. So the cavities in which the mirrors are reflect the light to and fro certain times, such cavity is known as resonant cavity. So the one of the mirror is completely silver and the second one is partially silver. These two mirrors along with the active medium form a cavity in which there are two types of wave. So in which they were interfere constructively if there is no phase difference between these two waves, and it interfere destructively when the phase difference is pi by 2. So we have the constructive interference for the formation of laser, so that the length can be determined, and the length between two mirrors or the distance between two mirrors is directly proportional to the lambda by 2. So L is equals to m upon lambda by 2, where m is integer value, it should be greater than 0. Now in this equation we replace this lambda by c by nu. This equation can be written as L is equals to mc upon 2 nu. So this is all about resonant cavity. Now the next point is there are various level laser systems like 3-level laser system and 4-level laser system. So let us discuss each one. So first is 3-level laser system. So why it is called as 3-level laser system? Because it consists of 3 energy levels, that is E1, E2 and E3. So out of which E1 is your ground state, E2 is your metastable state and E3 is your higher excited state. So atoms are pumped from E1 to E3 out of the two transition from E3 to E2 and E2 to E1. One is non-radiative spontaneous transition and other one is lasing transition. So atom will be pumped from E1 to E3 and it will drop to the E2 level by rapid decay, or we can say that non-radiative spontaneous emission. And the transition between E2 to E1 level is your actual laser point or the actual laser out, or we can say that it is laser action or the lasing action. Now the second level laser system is 4-level laser system. Why it is known as 4-level laser system? Because it consists of 4 energy levels, that is E1, E2, E3 and E4, in which E1 is your ground state, E4 is a excited state and E3 is your metastable state. So the pumping transition takes place the atom from E1 to E4, from where there is a spontaneous transition to E3. So this is fast non-radiative transition in between E4 to E3. And the actual laser formation will be takes place in the energy level E3 to E2, and in again E2 to E1 it is non-radiative transition. So this three level laser system will be observed in the case of ruby laser formation, and the four level laser system will be observed in the formation of Nd:YAG laser. Nd:YAG is what? Neodymium dot ytterbium aluminum garnet type of laser. Now, the most important type of laser is CO2 laser. So, it is your gas laser, and this question is asked on a previous exam for 6 marks. So, in this, let's discuss the CO2 laser. So, it is the first molecular gas laser invented in Bell Laboratories, USA in 1964. It is highest power continuous wave laser. The output power range of few watt to 15,000 of watts, and it produces the two wavelengths, that is 9.6 and 10.6 micrometers. The beam divergence is about 1 to 10 milliradians. So, this CO2 lasers is worked on the principle of vibrational modes of CO2 molecule. So, there are three modes of vibrations in CO2 molecule. First is symmetric stretching mode, second is asymmetric stretching mode, and the third one is bending mode. So, what is symmetric stretching mode? In this mode, your carbon atom is at rest and your oxygen atoms is moved towards or away from the carbon atom simultaneously. So, this type of vibrations are known as symmetric. That means your carbon atom is at rest and both the oxygen atoms move towards the carbon or away from the carbon atom simultaneously. In asymmetric stretching mode, one of the oxygen atom will be moved towards the carbon atom and another one will move away from the carbon atom. That means both the vibrations of the oxygen atom will be opposite. And the third mode is bending mode. In bending mode, your carbon atom is at one position and the oxygen atom move or vibrate perpendicular to the axis of molecule. So this is the actual working principle behind the CO2 molecule. Now let us discuss the construction of CO2 molecule. So it is a basically discharge tube having the cross-sectional area of 1.5 millimeter square and the length of 260 millimeter. The tube is filled with the active mixture of CO2, N2 and He in the proportion of 1:4:5. The terminals of the discharge tube is connected to the DC power supply. The two concave mirrors M1 and M2 is used, in which one is fully reflecting and another one is partially reflecting, which forms an optical resonator. So the active medium is a gas mixture of CO2, N2 and He. The laser action takes place between the vibrational states of CO2 molecule. So this is all about the constructions of CO2 molecule. Now the next is working of CO2 laser. So in working of CO2 laser, when we apply the current to the discharge tube, the electrons will pass from the discharge tube and it will excite the nitrogen atom first. So the nitrogen atom is at ground position initially. If we applying the current, the electron will strike to the nitrogen atom and therefore the nitrogen atom will get excited. So this equation represents the transition of nitrogen, that is N2 plus E star gives N2 star plus E. So what is this N2? N2 is nitrogen molecule in a ground state. E star is an electron with a high energy. And N2 star is your nitrogen molecule in excited state. So this excited nitrogen atom will collide or transfer the energy to the CO2 molecule. And and the population is created between E5, E4 and E3. During the transition E5 to E4, it will radiate a photon of 10.6 micrometer, and during the transition of E5 to E3, it will radiate a photon of 9.6 micrometers. So that is the actual laser out. After that, the atom from E4 and E3 will return to the E2 level. And at E2 level, your atom will losing all its energy. And for dropping the atom from E2 to E1, the helium plays an important role. Now this equation represents the excitation of CO2 molecules, or how your nitrogen atom will be transferred its energy to the CO2 molecule. So N2 star atoms gives the energy to the CO2 molecule, and the CO2 molecule will get excited, and therefore the transition of 10.6 9.6 micrometer we are observed, and we will get a final laser out. So this is all about working of CO2 laser. Now we will discuss some advantages of CO2 laser. So the first advantage is the construction of CO2 laser is very simple. The output from the laser is continuous. It has a high efficiency. It has high output power, and the output power can be increased by increasing the length of discharge. So this is the advantages. There are certain disadvantages for the formation of laser or the CO2 laser. So the first disadvantage is the contamination of the oxygen by the carbon monoxide has come effect on laser action. Now the second disadvantage is the operating temperature plays an important role in determining the output power of laser, and the third disadvantage is corrosion may be occurred at the surface of discharge tube. So this is all about today's session. Thank you all.